We're going to look at the function f of x is equal to 8 divided by 7 plus 3x squared, and we're going to write this as a power series. And power series are so beautiful. They are so wonderful. There's a lot that we can do with it. Before we even get into that, however, we're just going to have to go back and remember our geometric series. Because whenever we're working with a power series, this is the one that we want to go back to. So 1 divided by 1 minus x is equal to the sum of n is equal to 0 to infinity of x to the n. Now technically this is with our absolute value of x is less than 1. And this is a geo series. Notice I put this as a is equal to 1 in this geometric series, but this is basically what we're going to be looking at, is transforming our equation so that it looks like this side so that we can actually move it over to the right-hand side as a power series. So let's start off with our function. We know that we started it with 8 divided by 7 plus 3x squared. So we're just going to rewrite it just a little bit so that we get that formula that we're looking for. First thing that we're going to do is we're going to pull that 8 and that 7 off the top. So actually I'm going to leave the 8 there for now. I'm going to pull a 7 out of the denominator, out of both sides. Because notice we want a 1 minus x on the bottom, and so 1 plus 3/7 x squared is going to be what's going to happen when we pull that 7 all the way out, and then we're going to pull that 8/7 all the way out to the front, and we're going to be left with 1 plus 3/7 x squared. You're going to see how pretty that is, right? We are almost there. Next step, what we're going to do is we're going to rewrite that denominator just a little bit. Instead of 1 plus, we're going to take 1 minus a negative, because double negatives give us a positive. So this is going to be our setup. You'll notice now we have the basic setup, and all this stuff inside of the parentheses here are what we're going to replace our x with in our geometric series. So we're going to take all that junk and raise it to the nth power in a power series. And that is going to replace this entire stuff in the square parentheses in our brackets there. So we're still going to have the 8/7 out front. That is going to stay alive. And this is going to be simplified a bit. All right, so there's our 8/7, and instead of our fraction, we've got n is equal to 0 to infinity, and instead of putting an x here, we have negative 3/7 x squared, and this is to the nth power, and put in our square bracket. Next up, we're going to take our n and we are going to distribute that all the way across to everything. So we are going to have 8/7 and this is going to give us a negative 3/7 to the nth, x to the 2 times n. And now we can distribute the n into our second bit of parentheses there. Notice there's 3 places that we have to put it. It looks almost like it should be just top and bottom, but we've got this -1 hanging out here. And usually when we work with power series, if there's a -1, we want to have that distributed nicely so that we can see it's going to be an alternating series. So this is going to give us our 8/7, and then we will have our summation, n is equal to 0 to infinity. We'll have a -1 to the n, 3 to the n, over 7 to the n, x to the 2n. So one last step. Actually, there's two last steps here. Our first step is we are going to yank our 8/7 and we're going to pull it back inside of our summation. Whenever we have a summation like this, we can just move numbers on the inside and outside. Now that -1, I'm going to put out in front of our fraction, and I'm going to put that 8/7 with the rest of our fractions. So we have 8 times 3 to the n and 7 times 7 to the n. All right, now we got rid of our square brackets. There's one last thing that we can do. You'll notice in our denominator here, we've got a 7 times 7 to the n. Just kind of as an aside, don't forget, if you have x to the a, x to the b, you can always rewrite it as x to the a plus b, and some of your teachers may want to see that. So what we're going to do is we're going to rewrite this one last time. N is equal to 0 to infinity, -1 to the n, and on our numerator we're going to have 8 times 3 to the n. On our denominator, we're going to smush those two together to get n plus 1 as our exponent. And that is to the x to the 2n. So there is our solution for this particular power series. Don't forget, when you're working with the power series, you want to go back to the geometric, write it as 1 divided by 1 minus something, and then play around so that you get a nice output at the end. Thank you for listening.